today we are multiplying polynomials. This is section 7.2 of the book. I switched the homework, please note, to page 369, 1 through 43, all plus 45. Now, it will take longer as we begin, but it will get easier as we go because I will teach you a bunch of just memorization techniques. All right, so starting out by multiplying a number by the binomial, it is just using our distributive property, and we get 3x plus 12. If I multiply the monomial times the binomial, can't remember who said it, but we get 2a squared minus 10a. Remember, there's those imaginary ones as their exponents. They're there, we just don't write them. And then, sorry, my animations are off. When I multiply the last monomial by the trinomial, what do I get? Annabella?
12k cubed plus 24k squared minus 18k.
Good. So we get 12k squared cubed plus 24k squared minus 18k. And every time we use the distributive property. So basically everything we do today is really just the distributive property. Fancier ways to look at it, acronyms, tricks. We're just using the distributive property. All right, so when we multiply binomial by binomial, we basically are just double distributing. We're double distributing. So I take my first term and I'm going to multiply it by 2x, x times 2x, and what does that equal? Ryan? 2x squared, and then we do x times negative 3, and what does that equal? Everybody? Everybody?
Negative 3x.
Thank you. I want to hear everybody.
Negative 3x.
Okay, and then I'm going to distribute the 5 into the whole binomial, the positive 5. And so I get, everybody? Plus 10x, and then when I distribute here, minus 15. Now we combine our like terms, and we get 2x squared plus, what do these come to? 7x minus 15. Okay. Questions? Yes.
Technically, from there, couldn't you make it 4x plus 7x minus 15?
No, technically, I don't know where you're getting that from.
Because, oh wait, never mind.
Because why?
No, I answered my own.
Remember, these are not like terms, so I cannot combine them.
Right.
If you want to think of an x squared as the price of a large soda, and an x is the price of a small soda, I can't say that I have put the 2x squared and the 7x together, and it's all going to be times the same price.
Right.
Okay? It's really saying 2 times the large sodas plus 7 times the small sodas. Okay, so you can't put them, they'll never be the same price. All right, sometimes when I do this, I don't like the way I see their way. Okay, never. Sometimes when I do this, you might see me line it up like this. Switch colors. You might see me do x plus 5 times 2x minus 3. And I do 2x squared. And then I'm going to do again minus 3x. You might see me do this, plus 10x. I line it up with the like term. And then minus 15. And then I add going up and down. I have 2x squareds. If I have 10x's and I take 3x's away, I get plus 7x's minus 15. Is that making sense? So you might see me do it that way. I'm going to skip the vertical method. I can show it to you. Let me just show it really quick. When you do the vertical method, it's like you just line them up like you're doing regular multiplication. Don't write this down, just listen. Okay, we multiply negative 3 times 5. What does that equal? And negative 3 times x, negative 3x. And 2x times 5. And 2x times x. And I line them up again, and then we add them. Because this becomes very time consuming. Okay? We'll do that when we have big polynomials, more than 2, like 3 by 3, but not with these 2 by 2s, because I'm going to show you some mental math techniques. Okay? Memorization techniques. Okay. Questions? All right. So, what do you think this is? What do you think this equals? Shaylin?
X squared. Okay, x squared plus 3 squared.
Okay, which would be x squared plus 9, right? Wrong. This is the single most common mistake. What does this really mean? I don't want the answer, I want what it means, Ryan.
X plus 3 squared means x, parentheses x plus 3 parentheses multiplied by x plus 3.
The quantity x plus 3 times the quantity x plus 3. Now remember, we don't distribute exponents, and this will be this number one mistake that people keep forgetting about. This really means the quantity. What is the base of that exponent? What's touching it, the parenthesis. And what's in the parenthesis? X plus 3. So that has to be multiplied by itself 2 times. Now, when I multiply that out, I get x squared plus 3x plus 3x plus 9. They do it horizontally. Vertically, I don't really like it that way. And so really, what x squared plus 3, the quantity of x plus 3, really equals is, again, remember I'm doing x squared, 3x plus 9. We get x squared plus 6x plus 9. Okay, questions? All right, moving on. Okay. So, do you understand why we don't distribute? Now, somebody said to me, but wait, I thought we distributed before. No, we had a monomial. And we did something like this. That means everything inside there was, but we didn't go over that plus sign and distribute that square. We never do this. Don't do that. This, the whole thing is squared. 5 is squared, so it's, because really what this means is this. 5x squared times 5x squared. Do you understand? Yes or no? And that is 25x to the 4th. Oh, sorry. Oh, times 5x squared. Which really means 125x to the 6th. Am I clear? Okay. Or 5 cubed and x squared times the 3rd power, which is 125x to the 6th. Are you guys good with that? So let's not make that mistake. All right. Now, we've got ourselves a nice little binomial here. So what does it really mean? Let's do it together. What does this mean? Shaylin?
It really means 2x plus 5 to the 2nd power times...
No.
2x plus 5 times 2x plus 5.
Okay. And so I'm going to just do my double distributing. 4, what does it equal? 4x squared. And then when I go here, what does that equal? plus, Ryan, 10x. I'm going to do it here, plus 10x, and plus 25. Combine the like terms. 4x squared plus 20x plus 25. And it's not an equation, so don't go adding an equal sign there. We're just simplifying the expressions by multiplying. Okay, questions? Pause the recording and do number 2 on your own. So the question was, why is the 20x not squared? And the answer is because we are adding 10x and 10x, that makes 20 total x's, not multiplying. And we get them squared when we multiply. Pause the recording and do number 2. Let's get started on number 2. And so, first of all, what does it mean? Somebody I haven't heard from. How about Preston?
Should I just give you the answer?
I don't want the answer. What does this mean?
It means 3x minus 4 times 3x minus 4.
Good. Okay, where'd you start? Where'd you begin? What'd you do?
I multiplied 3x times 3x and I got 9x squared. And then I multiplied 3x by negative 4 and I got negative 12x. And then I multiplied negative 4 times.
Hold on. Negative 12. My pen's not. And then what?
And then I took negative 4 and I multiplied that by 3x. And I got negative 12x.
I got negative 12x. Are we done?
No, and then I multiplied negative 4 by negative 4 and I got plus 16.
Good. And what does it simplify to?
9x squared minus 24x plus 16.
Okay, so basically we have learned to just double distribute. Yes, I understand. No, I don't. All right, so now let's move on to some of the tricks of the trade. Tricks of the trade. Okay, so the first thing I want to say is a lot of times when you multiply two binomials, you will get a trinomial. You just really need this. When you multiply, most of the time, not always, there will be special circumstances that we will be talking about. Now, if I were to multiply this out, they're doing it vertical method. I can tell you it's going to be x squared minus 2x plus minus 15. Okay? You will get this. That first piece of the trinomial has a special name. Anything that's squared, what do we call that term? What'd you say?
Quadratic.
It's a quadratic term. Okay, so when you see x squared, it's a quadratic term. And then when you see just x to the first power, just like we did all semester, like y equals 2x plus 5, y equals negative 3x, what shape did it make when it was to the first power? A line. Not straight up and down, but any kind of line. So we call that a linear term. And then the last term has no variable, and we call that a constant term. So what they're saying is most of the time, 75% of the time, when you multiply two binomials, you will get a trinomial with a quadratic, a linear, and a constant term. Questions? Okay, can I move on? This takes too long, so we are going to use the acronym FOIL. Now, FOIL is a little bit outdated. I know a lot of teachers that don't like it, especially at this school. So I'm going to teach it to you because you may have some old-timer like me who was raised in the dinosaur age with FOIL, with the nuns and their rulers. Mr. Soto and Mr. Tomaszewski, they foiled me to death. Okay, but you get these young bucks like Mr. Chidas and Miss Emmer, and they'll be like, oh, FOIL, stop using that term. So I just want to bring it up so you know what FOIL means in case you get one of those old timers. It's really just double distributing. And what FOIL stands for is first, outside, inside, last. I learned it as first, outside, inside, last. My PowerPoint does first, outer, inner, last. Okay, and that means, look at my PowerPoint right now. Just look. Stop and look up. Jacob, stop and look up. First are the first terms. Last are the last terms in each binomial. Here's the last and here's the last. Outer is the outside of both binomials. And the inner is the inside, the two that are almost kissing. They're touching. Okay, questions? So when I multiply my first terms, what do we get?
X squared.
X squared. When I multiply my outer terms, what are my outer terms? What are the outer terms? X and negative 5. What do I get, Jacob?
You get negative 5x.
Yep. When I multiply my inner terms, what do I get, Jacob?
3x.
3x. And my last terms, please, Teddy.
5x. Negative 5x.
Nope. My last terms are the last of each binomial.
Negative 15.
Good. Negative 15. See that? So, now I put it all together and I get x squared minus 2x minus 15. So all it is an acronym to tell you to multiply the two first terms, then multiply the outer terms, then multiply the inner terms, then the last terms. But it's just double distributing. I'll explain why they don't like that term when we get to the end, when we use one of our end examples. Or I can say it now. The reason why they don't like this only works for a binomial times a binomial. Well, what happens when we have a polynomial or a trinomial times a trinomial? You're going to be missing terms. There's no first, outside, inside, last. So it's limiting, and that's why more recent teachers don't like that. It's limiting. They want you to think of it as just distributing. I distribute the first term in to both terms, and I distribute the second term. Whatever works for you. All right, so you guys try it. FOIL this one. Go. Pause the recording. FOIL. Yeah, so what would I do first if I'm foiling?
So you first find the first is the two m's.
Okay, and that would be?
M squared.
M squared. Okay.
And then for the outer, it would be m and 6.
Good, and that would be?
6m.
Okay, and the inner?
For the inner, it would be 3 and
And for the last,
it would be 3 and 6.
which is?
18.
Good. And it simplifies to?
M squared plus 9m plus 18.
Good. All right, so now let's look for some patterns, guys, because this is getting it's going to take you an awful long time if you can't do it mentally. Okay, I'm going to do a couple for you, and I'm going to see if you guys can find a pattern. So here's one. We said m is m squared plus 9m plus 18. Let's try m plus 2. Boy, that doesn't look like a 2. Times m plus 5. And that is m squared plus 7m plus 10. Okay, what if I have x minus, let's just first do x plus 6 times x plus 7 is x squared plus 13x plus 42. Okay. Michael.
The
and you get what two numbers?
The linear term, or the constant.
Okay, in the binomial, you can just say the 2 and the 5, or just give me specifics.
The 2 and the 5, the 6 and 7.
Okay, so notice, you add the 2 and the 5, and where does that go?
7m.
It becomes the coefficient of the linear term. Right? So the sum, so when I have this, the sum of these two numbers becomes the coefficient of the linear term. You guys with me? Does it work here? Do these two sum to the coefficient here? Do they add to it? What about here? Okay. Any other patterns you see, Ethan?
I would say it always goes quadratic term, linear term, and then constant term.
Okay, we got that already. But what other pattern? Did you pick up any other patterns?
That you always have that. You always have the exponent first because.
Okay. Luca?
Multiply the constant terms with
The two constants, when you multiply them, no, actually just say we multiply the two numbers that are by themselves, and it is the product here. Do you guys understand that? Did it work there? The two last numbers are the product. The two last numbers, are they the product here? When I multiply those two numbers, 6 and 7, does it give me a product here? So you see that little trick? So we can start to do these. So you write problem, answer, problem, answer. Okay? And it shouldn't really take you that long. So, let's go here. First term, we're always just going to, if it's the same variable, we just square it, right? Y squared. Let's go here. Okay, what's the second term going to be, please? Annabella?
11y.
11, because it take the sum of, and it becomes the coefficient of the linear term. Okay, Armine, what is the last term?
28.
Positive or negative?
Positive.
You have to say it, right? Next one, Shaylin.
M squared.
Uh-huh.
Plus 10n.
Good. Always remember that linear term. Good.
Plus 60.
Yep. Okay, next one. We're adding a negative to the mix. Who wants to try that one? Luca?
x squared
Uh-huh.
plus 2x.
Plus 2x, because I'm just taking a sum of positive 6 and negative 4.
And minus 24.
Minus 24. You guys with me? Okay, do 4 through 10, go. And please try and keep the m on this side for 9 and 10. Okay? You don't need to start with it. See what you can do with it. Pause the recording, finish through number 10. All right, so now let's check our work. So number 2 was m squared plus 10m plus 16. The next one is x squared plus positive 6, negative 4 is positive 2x plus minus 24. Next is t squared minus 4t minus 60. We have x squared minus 9x plus 20. We have x squared minus 5x minus 24. Y squared minus 16y plus 63. x squared minus 9x minus 22. Okay, now I want you to pay close attention because I know a lot of you are going to want to move this around into a different direction, but keep it in the same way that you're seeing it. Just multiply it out in order. We know our first terms, when I multiply it out, it'll be 14. I know my last term will be negative m squared. So now all you really have to do is figure out your inner and your outer term. Okay, your inner term is 7m, and your outer term minus 2m. So 7m minus 2m is plus 5m. Okay, the next one, we're going to have 24 on this side. We're going to have k squared, a positive k squared because of negative k. And my inner term is negative 4, my outer term is negative 6, so it makes negative 10k. All right, let's try some more. Now, just because I have a coefficient doesn't make things any different. I'm going to probably, I tend to go more to when I have coefficients and things change up, then I just use traditional double distributing method or FOIL. Same thing, remember? So I'm doing 2x times x is x squared, 2x squared. 2x times 6 is plus 12x. Then I do, so I did this and this, and I'm doing my 3 times x is 3x, and 3 times 6 is 18. So I get 2x squared plus 15x, it's supposed to be a 15, plus 18. Alright, so now I'd like you to, you can still do these fairly quick. I know my last term's going to be 35. I know my first one's going to be 2k squared. And now I know my inner term will be 10k, negative 10k. My outer one will be negative 7k, so it's negative 17k. Inner, outer, and that's how I come up with it. Now pause the recording and finish them the rest yourself. Okay, now let's check your answers. You should have gotten 2m squared, and this would be negative 30, and my inner term is going to be 12m, my outer term minus 5m, 12 minus 5 is 7m plus 7m. Sorry, I put that one so far off. Okay, my first one's going to be 3x squared. My last term is going to be minus 28. And my inner term is going to be 4x. And my outer term is going to be minus 21x. 21 minus 4 is negative 16x. 15, I've got 2x squared. I've got, my last terms are going to be plus 54. My inner term is going to be, I have a negative 9x and a negative 12x. That makes negative 21x. Next one, x squared times x squared is going to be x to the 4th. My last term is going to be negative 45. Inner term will be 9x squared minus 5x squared makes 4x squared. Okay, next. 6k to the third. My last term's going to be 3. My inner term will be 6k. My outer term, I'm not going to be able to combine them. So I'm going to put that 3 over here. My inner term makes a 6k. I should put this one over here. My outer term makes a 3k squared, and nothing can be combined. All right. Next one's going to be m squared. The last one, my last terms are going to be minus 25. Now notice this, my inner term is going to be plus 25, and my outer term is going to be minus 25. So that's it. They're going to cancel each other out. This is what we call a difference of squares. We'll learn more about that tomorrow. Okay, the first one's going to be 16t squared. The last one's going to be minus 49. Now, I've got plus 28 and minus 28, so that's it. Next one's going to be 2xm. So this is going to be quite different. My last is going to be minus 15. Two variables. I'm going to end up with at least 4 terms. 15. I've got plus 3m. And I've got minus 10x. And there's nothing that we can combine. All right. Check your work, and let's move on. So there's a couple other things that I wanted to show you. So let's first go to the first ones and say, let's say I have, this is what we call the box method or the table method. I think our book calls it the table method. I've seen it called the box method. So you can call it whatever you like. Okay, and I use this when I have something like 2x plus 3 times 4x plus, let's go 5. Okay, it's just another way to do it. I don't prefer to do it this way, but I want you to know of it. So I have 2x plus 3, and we have 4x plus 5. And so really it's an area model. So I take the binomials and I kind of split them up. And so in this one, this measure is 2x. This measure is 2x here, and this is 4x. So altogether, when I multiply them to get the area, I get 8x squared. The next one we said is remember we said this distance is a 4x, and this is a 3, so that makes 12x. This distance is a 5, and this distance is 2x. Altogether, when we multiply that out, it's 10x. And then I've got this distance, which is 3, and this distance, which is 5, and that makes 15. So my solution would be the 8x squared, my inner and outer terms make 22x, and my final term is plus 15. So it's just another way to do it. They call this the table, or the table method, or I call it the box method. But I think our book calls it the table. Okay, and the last thing that we're going to do today is when we have 3 terms by 3 terms, or more than 2 terms. When I have more than 2 terms, what I like to do is use the vertical method. Okay, so let's start with this one. X. I always take the bigger term and I put it on top. And bigger polynomial, put it on top. Smaller polynomial, put it on the bottom. And I stack them this way. Just when you start having lots of terms, it keeps things in order. And it's easy to sort things and put them in their own piles. So this is just like double-digit multiplication. I'm going to multiply 5 times 3 is 15. Next I'm going to multiply 5 times negative 4x. That's negative 20x. 5 times 2x squared is 10x squared. Now I'm going to take x and multiply it by everything. X times 3 is 3x. Now I'm going to line it up where my like terms are. So I'm going to put it in the pile where negative 20x is. So x times negative 4x makes negative 4x squared. X times 2x squared is 2x cubed. And now, because it's 2x cubed, it goes in its own pile. I add them up, and I get 2x cubed minus 6 and plus 6x squared minus 17x plus 15. So it's just another way yet, all of which is really the same thing as distributing. If you want to do it horizontally still, you can. But you can't use the idea of FOIL because there is no first, outer, inner, last. You will miss that middle term. So, take a minute and you try one on your own. Okay, now check your work. 4 times 1 is 4, 12x, and 4x squared. It's negative 12x, sorry. And 2x times 1 is 2x. Put it under the 12x. 2x times negative 3x is negative 6x squared. And 2x cubed. Line them up. Try another one if you want. Now try one with 3 and 3. It could be 3 and 3 and 4 and 4. We're doing the same thing. Now you add them up. All right. Try one more on your own. Pause the recording. Okay, now check your work. Okay, that's the lesson for the day.